which is compound inequalities. So a compound inequality is when you have two or more distinct inequalities joined by the word and or the word or. Okay, so we will have two different types of compound inequalities. Our first type of inequality we'll be looking at is our and inequalities. And inequalities is when the overlap of the two inequalities that form a compound where the solutions must satisfy both of the inequalities. Okay? Generally, an and inequality may look something like this, where you have two different points where the overlap between the 2 points is your solution. A good way to remember and inequalities is less than, right, for less than, where we have both of our less than symbols and less than or equal to symbol. Okay? That's a way to remember and inequalities. An or inequality is when solutions contain each graph of the inequalities, okay? So what this means is that solutions need to satisfy one of the two inequalities, okay? Generally, an or inequality will look something like this, where you have both of your points, but they are facing off in opposite directions. Okay, just like less than, we have a saying for or inequalities, which would be great or. Okay, which is obviously followed up by both of our greater than or greater than equal to symbols. Okay, so those are our two different types of compound inequalities that we'll be writing and solving within the next couple days. So we're going to start by writing our compound inequalities. So we have all real numbers that are greater than -2 and less than 6. So if we were to break this down, and is our key word telling us what kind of an inequality we're going to be having, with us having less than 6 on one side and greater than -2 on the other. Okay? So let's go ahead and write our inequalities. I'm going to start by writing each of these separate. All real numbers indicating just our variable. So our variable, which we can call x, is greater than -2. We can write that part. Then let's write the other part separately. X is less than 6. All right. So let's go ahead and write our compound inequality. We know that the lowest value x can be would be -2. So let's start by writing -2, which is less than x. And then let's write the other part of our compound inequality. X is less than 6. Okay, that is our and inequality. In the second example, we have all real numbers that are less than 0 or greater than 5. So, opposite of our last compound inequality, or is our key phrase in this one. On one half, we have less than 0, and the other, we have greater than 5. Okay, so let's write our two inequalities separately, and then let's put them together. So we have that x is less than 0, and x is greater than 5. So if we were to put these together and write them as a compound inequality, we have 0, which is the smaller of our two ends, which we know x is less than 0. Just make sure your inequality symbol is the same, the point being towards x, the point being towards x, and we know that x is greater than 5. You'll notice that our OR compound inequality faces the opposite direction of our AND compound inequality. When writing inequalities, a couple key phrases to look out for would be between, be between. That tells us that we are working with an AND compound inequality. The other type of inequality we need to look out for would be inclusive. Okay? This tells us or equal to. Okay, so if you see inclusive, know that we're going to have to use our greater than or less than or equal to symbols. And if you see be between, know that we're working with an AND compound inequality. Okay, so next we're going to start looking at how to solve compound inequalities. I will show you one example of both our AND and ORs, and we will do the other example when you guys get to class. So to solve an AND compound inequality, there is two ways we can go about this, and I'll show you both. Okay, the first way, maybe the most popular way, is to separate the two inequalities first. Okay, once you separate those inequalities, you will have to solve them, or more specifically, isolate the variable. Okay, once you've done that, just like all of our inequalities, you will go ahead and graph. Okay, so that is, one way to solve our compound inequalities. The other way, which I'll use green for, would be to solve/isolate first. Secondly, you would go ahead and separate the two inequalities. And then finally, you will graph. Okay, so there are a couple different ways you can go about solving your AND compound inequalities. Okay, so let's start diving into our first example here. Okay, I'm going to start by solving it the green way. So when you solve/isolate first, you are going to do all of your operations to both sides of your compound inequality. So if we were to try to solve/isolate for m, we need to start by adding 4 to both sides. Okay, make sure you do it to both sides of your inequality. -3 plus 4 gives us +1, which is less than or equal to m, which is less than -1 plus 4, which is 3. Okay, from here, we're going to go ahead and separate our two inequalities. We have our inequality on the left and our inequality on the right. So let's go ahead and separate them. Let's write them in the way that m is on the left side. So for our first one, we have m is greater than or equal to 1. And in our second inequality, we have m is less than 3. Okay? In our second way of solving these, we will go ahead and separate the two inequalities first. So we have our left side of this, which would be -3 is less than or equal to m minus 4, and then take the right side of our compound inequality. M minus 4 is less than -1. Okay, now go ahead and solve each of these separately. Add 4 to both sides. That will give you 1 is less than or equal to m, which can be written in the same form as what we originally had. And then we can solve our other inequality the exact same way. M is less than a positive 3. So as you can see, no matter which way we go about solving these, ultimately, we will arrive at the same solution. So the final thing we need to do is our third step, which is graphing. So, like always, we will have a number line. You can create your own in your notes. Okay, so when you're graphing a compound inequality, it's important that you plot both of your points with some sort of a point in between. So we can have 1 and 3 on our ends. And what comes between 1 and 3? Let's go with 2. Okay, so graph both of these separately. We have m is greater than or equal to 1. So that will give us a solid point at 1. We know m is greater than, so we're going to shade to the right. Okay, and then we have m is less than 3. That will give us an open point at 3, shading to the left. So the key here is we are only going to shade where both of our inequalities are true. Okay, which is that region between 1 and 3. Okay, so please let me know if you guys have questions on that example. I know these are a little bit confusing and definitely a step above what we have worked on in class this far. Okay, so I'm going to save the second example here for class. We can work through it together and make sure that everyone is understanding the steps that go into this. But just a reminder, you can solve these using either of the two methods. Okay, finally, we also will have to solve OR inequalities. These ones are slightly easier because we don't have to do any kind of separation or anything like that. They will always be separated with OR in the written problem. So what we have to do is solve each side separately. So for this side, let's isolate our variable by subtracting 2 to both sides. This gives us 3t is less than negative 7. To isolate our variable, we will divide both sides by 3, leaving us with t is less than negative 7/3. And we will have to leave it as a fraction. Okay, for our second side here, we need to subtract 5 from both sides. That will give us negative 4t is less than negative 4. So now to solve for t, we will divide both sides by negative 4, leaving us with t is less than 1. Okay, so now we have already solved for both of our sides. We don't need to do anything overly fancy to get here. Now let's go ahead and create our number line. Doesn't have to be perfect. With both of our ends being 1 and negative 7/3. And then we'll just estimate a point in between, which honestly, let's make it easy and just go with 0. Okay, doesn't have to be perfect. So let's graph each side separately. We have our variable on our left side, so we can just follow the way that our inequality symbol is facing. So at negative 7/3, we will have an open point because we just have a less than symbol. And we know that we'll have to shade to the left. On our other side, we have t is less. Oh, wait, I made a mistake. So here, I divided by a negative. I totally forgot. We need to flip our sign. Okay, so let's go back and make sure we are flipping our inequality sign. Okay, Remember, when you multiply or divide by a negative number across your inequality symbol, make sure you are flipping the sign. But now we have t is greater than 1. So, similar to what we had before, you will still need an open point. But now our inequality arrow is pointing to the right or the positive direction. So there we go. Once again, I expect that you guys try the second example on your own. Come to class with some questions and we'll walk you through an example. Okay, thanks for watching. I look forward to answering your questions in class.